this computer. I'm going to share my screen so we can see what people have done. So, room number 1. Want to take us through what you did? Anybody from room 1?
Guys, we can do like the same orders last time, maybe.
I think it's fine if you just do it.
I don't know. Think about your portfolio. Like, you know, this could be a video where you actually like explain stuff. So I don't know. Just putting it out there. There is still a portfolio. So
I can go.
yeah.
So the things we know were that the force tension equals the force of gravity, and the gravitational force equals 9.89 newtons over kilograms.
And we wanted to figure out the mass of the ball creating tension on the rope in kilograms.
Mm-hmm.
And the relationship is Ft equals Fg, and m equals Fg divided by Earth's gravitational force.
Okay.
Yeah, we had no algebra. This is not a problem where we needed algebra, and the work is down below. So basically, it's like the relationship said. We took to find the mass. We took the Fg they already gave us and divided it by Earth's gravitational field strength,
Mm-hmm.
and that's how we got our answer. I should also probably explain the beginning a little bit more. So, the sphere is at a constant velocity right now. And based off of that, we know it's balanced, because if it's a constant velocity, it's going to be balanced. The forces will be balanced. Right over here, I don't know if there's a way for me to highlight that, but on our left, there is a force diagram, and you can see the congruency lines representing that the forces are balanced. And we also know that the net force on the sphere is 0 because the forces are balanced. Okay.
Awesome.
That was our
So let's see, room 3, you were supposed to have done this problem also. Where is your board, room 3?
Oh, it's like on slide 8.
On slide 8. It's tricky. Okay, anything you want to add to what they said?
I guess not necessarily. It's pretty much the same.
Okay.
Yeah.
I like the use of the arrows for the force diagram. That's neat. Makes it nice and clean. I would say go like tread like so. Actually, no. There's one thing. Like somebody spots something weird on this slide that they want to sort of like something that doesn't quite fit. See if we can pay attention to details. What's something on this slide? Can I see you? Let's wait a second, see if other people can spot it. What's one thing on this slide that's a little bit weird? Kate, I see you also. Let's see if we can wait. Natalia's seen it. Ramsey, maybe. Lowell has it. What is weird on this slide? It's a mistake. It's not a big mistake, but it's a mistake nonetheless. Natalia.
For E,
Yeah.
talking about the mass, but they put newtons.
Yeah. Make sure your units are valid. Okay. Your units, in this case, it's a mass, should be in kilograms, not in newtons. Let's see. Problem number 3. For example, room 4.
Okay, I can explain the first bit. So you were like working with a block, and it was just resting on the floor. So we knew that the forces, like the force diagram, it would be balanced because their block isn't moving in any way.
Yeah.
And so it has a normal force and a gravitational force that are equal. So then the net force we knew would have 0 newtons.
Okay.
And Hayden, do you want to explain the other part a little bit more?
So we know that the forces are equal, and meaning that gravity and the normal force are equal to 3.55 newtons. Then we're trying to figure out the mass of the block. So we put 3.55 is equal to 3.55 newtons is equal to 9.81 newtons per kilogram times mass. And then we divide by 9.81 newtons per kilogram, and we get 0.36 kilograms.
Cool. Thank you. Let's see. Room 2. Anything you want to add to that?
No, we basically agree with what they said.
Okay.
Yeah.
Yeah, my only comment is make sure that you really put, like, every time you put a number, you put a unit, right? So that would be that. And let's see, room 4, you also had the same problem. Anything you want to add? No, you just answered. You said room 5.
Yeah,
No.
despite our our slide being very chaotic, we had a very similar solution to room number 4.
Awesome. Great. Thank you. Good work. Stop sharing.